In this lecture, we are going to discuss one more problem on the basis of decision making under uncertainty. We had seen one problem in the previous lectures and we had solved that problem by considering 5 different criterion. Let's give a brief recap of all those criterion by considering this problem. So we can see that in this problem, rather 4 actions are given. Okay, we can see that these are the 4 strategies or course of actions. And we also have the same number of states of nature, that is n1, n2, n3, n4. So this is the matrix given here. Okay. What will we do in this problem is that we will consider it to be both as a maximization matrix at one time and the minimization matrix at other time. Okay. So we know that maximization matrix is also known as the payoff matrix or the profit matrix. If this is a maximization matrix, then all these quantities mentioned in this matrix will be of the profit. And this matrix is also known as the payoff matrix. Had this been the problem of minimization, then the elements mentioned in this matrix would have been of the cost or loss. Therefore, we can say that this would have been a loss matrix or a cost matrix because we want to minimize the cost and the loss. So we can see that there are 5 criteria. The first criteria is optimism criteria. So actually the optimism criteria is of 2 types. Okay, although I might have not discussed both types in the previous lecture, but you can add this into your notes. It is classified into 2 criteria. One is the Maximax criteria and another is the Minimax criteria. Okay, so usually the matrix is a payoff matrix or a profit matrix. Therefore, we usually consider this Maximax criteria. Okay, so this Maximax criteria is actually for the this is for the maximization problem. And this minimax criteria, sorry, this is minimin in fact. Okay, just a correction here, it is minimin. So this optimism criteria can be classified into maximax and minimum. Minimin criteria. Okay, so this minimin criteria will be used when if this table is considered to be a cost matrix or a loss matrix. Therefore, this minimum problem will be used for minimization matrix. Okay, so let's solve this problem. So if we are solving this by an optimism criteria, and in the first case, I am considering this matrix to be a maximization problem, or we can see that this is a payoff matrix or a cost matrix. It is a profit matrix. Since this matrix I am considering to be a profit matrix, therefore, for this profit matrix or the payoff matrix, since this is a problem of maximization, I will use this Maximax criteria. That is, I will calculate for each action. Okay, for each action I will calculate the maximum value or maximum payoff, and after that I will select the maximum among all those maximum payoffs. So see here in the first strategy or in the first course of action, we can see that this maximum payoff is equal to 1500. In the second course of action, we can see that the maximum payoff is equal to 3750. In the third course of action, we can see that the maximum payoff is equal to 4750. And finally, in the fourth course of action, we have the maximum value of 4000. So what does Maximax criteria say? Select the maximum among the maximum. Okay. So we have selected all these 4 maximums, and among them, what is the maximum value? That is 4750. And corresponding to this maximax, we have the S3 course of action. Therefore, from the Maximax point of criteria. If this is a maximization problem, we have to use the Maximax criteria. Then this course of action S3 or strategy S3 will be the optimal strategy. Now, considering this table to be of the minimization, if I consider this table to be of the minimization, okay, had this been a minimization problem, then this matrix would have been cost or loss matrix. And the criteria that has to be used here for the minimization problem is minimin. Okay, so minimin means minimum of the minimum. Therefore, in this case, we have to first select all the minimum values for each course of action. So here in the first course of action, the minimum value is 0. In the second course of action, the minimum value is equal to 250. And this minus 500 is the minimum value for the third course of action. And finally, minus 1250 is the minimum value for the fourth course of action. So we have seen all these. We have calculated the minimum values for each course of action. And the minimum, that is the minimin criteria, suggests that select the minimum among the minimum. Okay, that is equal to minus the minimum value here is among the four will be minus 1250. So the corresponding strategy or the course of action is S4. Okay, so this will be selected as per the minimin criteria. Okay, if this is a table of minimization. So after that, we had seen the pessimism criteria. Okay, we had seen the pessimism criteria. So again, this pessimism criteria can be divided into two parts. I can write it in the first slide. I might have discussed it in the previous lecture only for the maximization problem, but for the maximization problem, we will have one criteria. And for the minimization, we'll have another criteria. And for the maximization, I had told you that the criteria is Maximin criteria. And for the minimization problem, okay, if this matrix is a minimization, that is the cost or loss matrix, then the criteria that has to be followed is minimax. So let's first consider this table to be of the maximization matrix. That is, this is the profit matrix. If this is the profit matrix, then the criteria that will be used is Maximin criteria. Okay. And similarly, in the second case, what I will do, I will consider this problem to be of the minimization problem. If this is a minimization problem, that is, the matrix could be the cost matrix or the loss matrix. And correspondingly, the criteria that will be used is the minimax criteria. So let's calculate this. So maximin means that first of all, we have to calculate all this minimum. Okay, maximin means maximum out of the minimum. So if we first have to calculate the minimum values and then select the maximum out of those minimum. In the second case, we have to select the minimum out of the maximum. Therefore, first of all, we have to calculate the maximum values for each course of action, and among them, we have to select the minimum. Okay. So first of all, going to this maximization matrix, the criteria used is Maximin criteria. Therefore, what we have to do, we have to select the minimum values. 0, this will be 250, this will be minus 500, and this will be minus 1250. Now, as per the Maximin criteria, select the maximum out of all these minimum, and you can see that the maximum value is for 250. Therefore, the corresponding course of action will be S2. Similarly here, in this, if this problem would have been the minimization problem, then we have to use the minimax criteria. That is, first of all, we have to write the maximum values. Okay, we can see that this will be equal to 1500. The maximum value for the second course of action is 3750. Similarly, 4750 and 4000. And among them, we have to select the minimum value, that is 1500. Therefore, and this corresponds to S1. Okay, so these are the optimism criteria, and we have discussed the both the cases. For the optimism, if it is a maximization problem, we will use the maximax, and if it is the minimization problem, we will use the minimin criteria. Okay, and after that, had this been, now this was actually the pessimism criteria. Okay, for the pessimism criteria, again we have two criteria. One for the maximization problem, and that criteria is maximin criteria. And for the minimization problem, that is if the cost or loss matrix is given, we have the minimax criteria. After that, we had also studied this, what we call as the Laplace criteria or equal probability criteria. Now what we did in this criteria, that is Laplace criteria or equal probability criteria, we calculated the average payoff for each course of action. And for the minimization problem, we selected the minimum payoff or the minimum average, and for the maximization problem, we selected the maximum payoff. Okay, so we can see that the expected payoff, okay, if we want to write the expected payoffs, or in other words, we are going to say that we are giving each course of action equal probability, that is 1 by 4 in this case, because there are 4 states of nature. Okay, so for the first course of action, or for the first strategy, the expected payoff will be equal to, it will be the average, that is 1000 plus 1500 plus 750 plus 0 divided by 4, and that will be equal to rupees 812.5. For the second course of action, we can see that the expected average will be equal to 250 plus 2000 plus 3750 plus 3000 divided by 4. So this will be equal to rupees 2250. Similarly, for the third course of action, the average will be equal to minus 500 plus 1250 plus 3000 plus 4750 divided by 4, and this will come out to be rupees 2125. And for the fourth course of action, we can see that the average will be the summation of minus 1250 plus 500 plus 2250 plus 4000 divided by 4, and this will come out to be rupees 1375. So now, had this been a payoff or this profit matrix, then as per the Laplace criteria, the optimal course of action would have been the one having the maximum expected payoff. Okay, so this will be for what we call as the profit matrix or payoff matrix. And the least value among them is rupees 812.5. So this course of action, that is S1, will be selected for loss or cost matrix, that is for the minimization problem. Okay, so indirectly you can say that this is for the minimization. and this has to be selected for the maximization problem. Now let's see another two criterias. The fourth criteria which we had studied was the Horix criteria. Okay, so according to this criteria, what we did is we calculated a parameter that is known as H for each course of action, okay, HSJ, and it was given by alpha, which is the degree of optimism, into the maximum value or maximum payoff for a particular course of action plus 1 minus alpha multiplied by the minimum payoff for a particular course of action. So here we have four strategies, okay, or four actions. So therefore, we have to calculate four values of H, and depending upon the values of H, if I treat this to be the maximization problem, I will select the one which is having the highest value of H. Okay, so we can see that for the first course of action, and let's also assume that alpha is equal to 0.6 here. So for the first course of action, okay, for the first course of action, that is for S1, the H value will be equal to the maximum value among these is equal to 1500. Okay, so alpha will be multiplied with 1500, that is 0.6 into 1500 plus 1 minus alpha will be 0.4, multiply it with the minimum value that is equal to 0. Similarly, we can find the value for S2, that is H of S2 will be equal to 0.6 into the maximum value here is 3750 for the second course of action, plus the coefficient of pessimism is 0.4, and the minimum value among all these is 250 for the second course of action. So we will get another value of H. Similarly for S3, HS3 needs to be calculated. Therefore, it will be equal to 0.6 multiplied by the maximum value that is equal to 4750 plus 0.4 into the minimum value which is equal to minus 500. And finally for the S4 we will calculate HS4, that will be equal to 0.6 multiplied by the maximum value that is 4000 plus 0.4 multiplied with minus 1250. So we can see that these values will be equal to, this value will be equal to 900, this will be 2350, 2650, and 1900. So since this problem we are going to treat as the maximization problem, therefore we have to select the one which is having the maximum value. Okay, so S3 for maximization problem. If the same problem is to be considered as the minimization problem, then the formula of H changes, and that is equal to so H will be equal to alpha into the maximum value, sorry, alpha into the minimum value plus 1 minus alpha into the maximum value. Okay, maximum this element for each value of for each course of action. And since this is the problem of minimization, the one having the least value of H will be selected. Okay, so we need to calculate these h values for each course of action. So hs1 will be equal to alpha is equal to 0.6 multiplied by the minimum value, that is equal to 0, plus 1 minus alpha, that is equal to 0.4 multiplied by the maximum value, which is equal to 1500. This h value for the second course of action will be equal to 0.6 multiplied by the minimum value, that is equal to 250, plus 0.4 multiplied by the maximum value, which is equal to 3750. HS3 will be equal to 0.6 multiplied by the minimum value, which is equal to minus 500, plus 0.4 multiplied by the maximum value, which is equal to 4750. And finally, HS4, that is 0.6 multiplied by the minimum value, which is equal to minus 1250, plus 0.4 multiplied by the maximum value, which is equal to 4000. So let's calculate them one by one. We can see that these values will be. So these are the values which we obtain after the calculations. And since this is the problem of minimization, therefore, the optimal value which we have to select is the minimum value. And the corresponding course of action is S1. Therefore, this will be selected. Now, the last criteria was what we call as the regret criteria. Okay. Or that was the minimax regret criteria. And what we had to do here in this, we had to calculate, create another table that was known as the regret table. And now considering this to be a maximization problem, for each what we call as this state of nature, okay, for each state of nature, we can see that we had to subtract the payoff from the maximum payoff. Okay, so here the state of nature column here is this n1. Okay, we can see that the elements are at 1250 minus 100 and minus 1250. So from here, what we have to do here is, first of all, we have to select the maximum cost in a particular state of nature. Now we are considering the first state of nature, the maximum cost is 1000. We have to, from this 1000, we have to subtract each payoff. Okay, so 1000 minus 1000 will be 0. 1000 minus 250 will be 750. 1000 minus 500 minus 500, in fact, will be 1500, and 1000 minus 1250, that will be equal to 2250. Okay, similarly for all the other states of nature, we have to calculate the regret table. So this regret table can be written here. This is the regret table. These are the states of nature n1, n2, n3, and n4. They will be revised. Okay, they will get revised, and we can see that the elements will be now in the first state of nature, 1000 is the maximum. Therefore, 1000 minus 1000, that will be equal to 0. 1000 minus 250, that will be equal to 750. 1000 minus 500, that will be equal to 1000 minus 500, that will be equal to 1500, and 1000 minus 1250, that will be equal to 2250. This is 1500, and this will be 2250. Similarly, in the second state of nature, we can see that the maximum value is equal to 2000. Therefore, 2000 minus 1500 will be equal to 500. This will be 0, and this will be 750, and this will be 1500. In the third, what we call as the state of nature, we can see that uh, the maximum value is 3750. Therefore, 3750 minus 750, that will be equal to 3000. This should be 0, this should be 750, and this should be 1500. For the last definition, the highest value is 4750. Therefore, 4750 minus 0, it will be the value as it is. 4750 minus 3000, that will be 1750. This has to be 0, and this has to be 750. Okay, so this is the regret table. Now for the particular course of action, we have to see the maximum regret. Okay, for the particular course of action. So see, this is the first course of action is S1, second course of action is S2, third course of action is S3, and fourth course of action is what we call as the S4. So among them, in the first course of action, the maximum is 4750. I can write here. The maximum is 4750. In the second course of action, the maximum payoff is equal to 1750. In the third, it is equal to 1500. And the fourth, it is equal to 2250. So what does Minimax criteria suggest? That out of the maximum regrets for the first course of nature, I mean to say out of the maximum regrets for all these courses of nature, then we have to select the minimum. And we can see that the minimum regret among these is for course of action S3, because it is only 1500. Therefore, from the Minimax regret criteria, it can be concluded that this what we call as this minimum regret is equal to 1500. Okay, out of the maximum regrets, we have to see which is the minimum regret, that is 1500. Therefore, the course of action S3 will be the optimal among them. And finally, if we consider this to be the minimization matrix, we had seen that for the minimization, what we do is we calculate the cost minus minimum cost. The regrets, okay, the regrets will be given by the cost minus minimum cost for a particular state of nature. Okay, so if we draw the regret table here, we can see that this is N1, this is N2, this is N3, and this is N4. So in the first, okay, in the first state of nature, the minimum value is equal to, or the minimum cost is equal to minus 1250. Okay, so this 1000 will become cost. Okay, it is a cost minus minimum cost. 1000 minus 1250, it will become 2250. This 250 minus 1250, it will become 1500. Minus 500 minus 1250, it will become 750. Minus 1250 minus 1250, it will become minus 1250 plus 1250, and that will be equal to 0. In the second column, or in the second state of nature, the minimum cost is 500. Therefore, 1500 minus 500 will be equal to 1000. 2000 minus 500, it will be equal to 1500. This will be equal to 750. And finally, this will be equal to 0. In this third state of nature, the minimum value is equal to 750. Therefore, 750 minus 750 will be 0. 3750 minus 750 will be equal to 3000. Similarly, other values will be equal to 2250, and this value will be here equal to 1500. For the fourth state of nature, we can see that the minimum value is 0. Therefore, 0 minus 0 will be 0. 3000, the other elements will remain as such. And out of these regrets, for each course of action, we have to see the maximum regret, okay, because we are using the minimax criteria, okay, whether it is the maximization problem or it is the minimization problem. In both the cases, we have to see the minimax regret. Therefore, the maximum regret for this will be 2250. The maximum regret for this is equal to 3000. Here the maximum regret is 4750 and the maximum regret is 4000, and the minimax regret says that choose the minimum out of all these maximum regrets. Therefore, it should be equal to 2250. And this corresponds to S1 course of action. Okay. So in the next lecture, we are going to discuss the decision making under risk, and in the final lecture, we will discuss the decision trees. Okay. So we are left with two lectures, hopefully, and that will be discussed tomorrow.